All right, so number one. We got just over an hour. Good, I think we can get it done. So just number one, got to factor. Got to factor those denominators, I'm sure you know. Okay, so factoring y squared minus 3y plus 2. Yes? What's the name? Antonio. There he is. Thank you. Everybody get theirs back? We good? All right. So, okay. So, number one, adding fractions got to factor the denominators. So, how do you factor y squared minus 3y plus 2? Looking for two numbers that multiply to be 2 and add to be minus 3. Like, what times what is 2? 2 times 1. Yeah, 2 times 1 will multiply to be 2. And what's going to add to be negative 3 if they're both negative, huh? Yeah, both negative. Yeah, because negative 2 times negative 1 will make positive 2. It'll multiply to be plus 2, and they'll add to be negative 3. Very good. And then y squared minus 1. You know that one. Y plus 1, y minus 1, huh? We all good so far? Now, what do we... remember, we have two kind of different things we're doing in this chapter. This is what I really want to be helpful to you about. We keep the balance two ways. Left, right, top, bottom. Remember those two different ways of keeping the balance? How do you know which one to do when?
Equal sign.
If you have an equal sign, then you have a left and a right. And you don't worry about top, bottom. But if you don't have an equal sign, like this one, number one, then you got to do top, bottom. That's the give them what they're missing, top and bottom kind. Everybody good on that difference? That's a big point. So, equal sign, let me just write that somewhere. I don't know where to write it. So, well, I'll just say no equal sign. No equal sign. So, top, bottom. So this is a top, bottom problem, not a left, right problem. Because there's no equal sign here, right? No equal sign. So I don't really have a left and a right that are equal. So I can't do the same thing to the left and the right of an equation. There is no equal sign. So what do? Top, bottom. So that's the, give them what they're missing kind of thing. Come to this one. What's this denominator? You want to make the two denominators the same, right? What's this denominator missing that the other one has? Y plus 1. Give it to him top and bottom. So I'm doing the same thing top and bottom, balance, right? So I'm not changing that fraction. And now come to the second one. What's the second one, the denominator, missing that the other one has? Y minus 2. And give it to him top and bottom so you don't change anything. See how the two denominators are the same now? See how I filled in their gaps. I gave them what the other one was missing, or what they were missing that the other one had. So they're the same. They have the same three pieces. Doesn't matter what order you put them in. I'll just put y plus 1, y minus 2, y minus 1, whatever. Or whatever order. They both have the same three things in the denominator now, right? Common denominator, that good? Give them what they're missing. Top and bottom. Now, what do we do on the top? Multiply it all out. Gather like terms. So the 3 is going to go boom, boom. 3y plus 3. The 5 is going to go boom, boom. Plus 5y minus 10 equals, what is that? 3y and 5y, 8y. 3 minus 10 minus 7 over that common denominator. We're done. 8y minus 7, 8. No, wrong denominator. I better look at the denominator a little closer. I was trying to show you how easy it is to be fooled on these multiple choice answers. Yeah, it looks like it's none. That is tricky.
That's how bad we're
Yeah, that's right. Evil. Is that okay? Yeah, that's tricky, isn't it? That's a little tricky. And it's disturbing, huh? You think, well, I got it, and it's not there. I must have messed up. No. If it's not there, just none of the above, and off you go. But I almost tricked myself there. I didn't. That denominator is missing the. It was almost A, huh? Except it's missing the the other piece. It's only got two pieces.
Almost is not quite.
Yeah, almost only works in horseshoes and hand grenades. My dad used to always say, right? So, right? We good there? That all well? So it's E. Is everybody okay with that? So when there's no equal sign, top and bottom. No equal sign, top and bottom. Give them what they're missing. Make the two denominators the same. All right, on we go. That's not number 2.
That's number 2.
Well, it's not the way I want number 2. There. There's number 2. All right, so what about this one? He's got a couple issues. Never subtract. Remember that issue?
Yeah.
Never, ever subtract. Let that minus sign go to the upper right. Remember that? Remember we always take minus signs upper right? Never leave a subtraction symbol in the middle of two fractions. Move it to the upper right. Always. So that minus sign is going to go right there. So this will become 6 over 7x minus 8. Plus, right, the minus sign will leave and go on to the 3. Oops, this is 8 minus 7x. Yeah, something else we got to do too. But everybody good so far, right? We never subtract fractions. Subtraction symbols in the middle, we move to the upper right. In other words, we're adding negative 3, which is the same as subtracting 3, isn't it? Adding negative 3 is the same thing, but that way you won't tend to forget that minus sign when it comes to all the multiplying and everything. So easy to forget that thing. So anyway, that's why I suggest you never subtract. So, okay, now what?
Now you multiply the second term by negative 1.
Yeah, now we have x subtracted at the back. Whenever you have the x term subtracted at the back, we don't want that. What do we do with that? We multiply top and bottom by, negative 1 over negative 1. You with me? Negative 1 over negative 1. That flips around, doesn't it? Remember, that's called the turnaround rule. So I come in there and I go minus 1, top and bottom. Because we do not want x subtracted to the back, we're going to make a match. And so that'll make this one flip around and become 7x minus 8. Won't it? And what will it do on the top? Plus 3. Everybody good there? See how it made the bottom flip around? If you multiply, you'll get minus 8 plus 7x, which is 7x minus 8, isn't it? Do you see how distributing that minus through the bottom effectively, it changes both signs, which is the effect of turning it around. Everybody see that? So, what does that mean then? So what do we have? We have 6 over 7x minus 8 plus 3 over 7x minus 8, which just adds up to be 9 over 7x minus 8. There it is. A it is. Good on that? Everybody good? So 2 little tricks there. Never subtract. Move it to the upper right, and then multiply top and bottom by minus 1. Turns around the bottom, makes the top back into a plus 3. I'll move on if you're okay. All right, so number 3, same kind. Never subtract. Take that minus, move it to the upper right. Okay, we're going to have add negative 6 in the middle, huh? All right, so then factor x plus 4, x minus 4. Factor the other one, x plus 4, x plus 1.
Yes.
Right, it has to multiply to be 4, add to be 5.
Yes.
We good to there? We never subtract. Move subtractions to the upper right, add the opposite. Okay, now, is this one have an equal sign or not? No equal sign. So I'm not doing left-right. I'm doing top-bottom again. So give them what they're missing, top and bottom. What is this guy missing, top and bottom, that the other one has? The x plus 1, huh? X plus 1. X plus 1. Top and bottom. What's this guy missing that the other one has? X, yeah, the minus 4, huh? That good? See how the two denominators have the same 3 pieces now? Common denominators. So now I can combine them into one big fraction. Don't need 2 of them any longer. Right? All right, what does that give us? Well, the x will distribute like that. So it would be x squared plus x. The minus 6 will distribute. Minus 6x plus 24. Am I going too quick? Is that okay? Everybody see what's happening there? So I never subtract, move it to the upper right, move subtraction symbols to the upper right, and then I factored the denominators, and then I give them what they're missing, top and bottom, to make the two denominators the same, common. Then I just multiply out the top, gather like terms. What do we have? X squared plus x plus 1x minus 6x is minus 5x.
Plus 24.
And then over the LCD, that denominator.
Yeah.
So x squared minus, is it a again? I'm a little nervous to grab a so quick. Is that, yeah, that is a. There it is. Questions I can answer? No questions? Is it all good?
On four.
All right, I'll move on.
4 is super easy.
Got a copy. Now this will be on YouTube right after class if I'm going to. All right, number 4. Oh yeah, you just cancel, huh? That's a really nice one. That's your favorite question. Here we go. Another.
You're still wrong. It's 5y over 2.
Oh man. Multiple choice is rough. There we go. I just want that A. I'm just grabbing that A too quick. 5y over 2. Thank you. 5y. I forgot the y. Don't forget the y. Good. On we go. How about number 5? We need the 45 simplifies. 5 times 9. The 9 is 3 times 3, right? Okay, if I squeeze that in right there. So I broke down that 45. Again, 45 is 5 times 9. 9 is 3 times 3. And then, well, what's in the hook on number 5? What's in the hooks? Nothing, 2, therefore, right? It's invisible 2. Only invisible 2 that I know of in math. So the 2 3's in, send 1 3 out, to multiply that 4 to make 12. It's not on the hook. Kind of looks like it's on the hook the way I wrote it. So it's right here. 3 times 4, huh? Good. So what is that going to be? I'll bring this down here. So it'll be minus 9 root 5 minus 3 times 4, 12. What's left in the root?
5.
Yeah, there's 5. So far, so good? Everybody see what's happening? So that a 3 was sent out, right? The 2 3's in, sent 1 3 out, hits the 4 that's already out there. 3 times 4 is 12. So now these are like terms, aren't they? Remember, same roots, like terms. Minus 9, minus 12, what is that? Minus 21, roots of 5. D. D it is. Good? On that one. Moving on. Is that okay? Questions? Car, was that you? No? All well?
Because of the first term.
Let's see. Number 6. Okay, so first term is root of 5a. Next term, that 45, I'm going to have to break that down, huh? And the 180 as well. Okay, so let's break some things down here. 45, 5 times 9, 9. 3 times 2. 2 3's in, 1 3 out, multiplies that 7. So it's going to be root of 5a minus 21 root of 5a. Good so far? Right, I broke down that 45a. 45 is 5 times 9, 9 is 3 times 3. 2 3's in, 1 3 out, 3 times 7, 21. Leaves behind a 5 and an a. Like that. Next one, 180. Well, that's 18 times 10, right? Things that end in a 0 or times 10, right? And then 18 is 2 times 9. 10 is 2 times 5. 9 is 3 times 3.
So you got 2 3's and 2 2's.
Yeah, 2 2's, 2 3's. So here, bring it down to the, you can bring everybody down to the bottom line, might be helpful. So there's the guts of a 180 and the A, even if you want to bring everything. So there's the guts of a 180A. So 2 3's, 2 2's, So out comes, yeah, a 2 and 3, which is 6, times 5, which is going to be 30, plus 30, whoops, get a little scribbly here, plus 30 root of what's left inside? 5a right here. How we doing? Am I losing you? You tracking with all that breakdown of all those little numbers?
Okay, what got me was
There's a 1 there.
Yeah,
Yep, gotta be careful.
There's supposed to be a 1 there, because like,
Right.
we did a couple where we didn't include it because it didn't have a number before it. Like, a couple.
Let's show me an example.
Yeah.
So we good with all the breakdowns. All the breakdown good with the 180. Broke it all down. 2 2s, 2 3s. So out comes a 2 and a 3, which is 6 times 5, which is 30. Now, let's finish this up right here. It's 1. Yeah, don't forget about that 1 in front of the root. There's an invisible, understood 1. They're all over the place. These invisible 1s, aren't they? You always got to know about them. 1 root of 5a minus 21 would be negative 20, plus 30 is plus 10 root of 5a. The invisible 1, you forgot about the invisible man there, the invisible 1? There it is. That good? Good? Question about, you good with the 30? Yeah, because 6 times 5, 2 times 3 times 5? Good, we all well? No questions on that one? All right. So what's different about number 7 from any of the problems we've done so far? Got an equal sign, exactly. Are you dialing in with that like Abraham is? You got to be right on that. That's really important, equal sign or no equal sign. So here we have an equal sign. So all of my thinking now is left, right. I'm not thinking about the bottom. Right? I'm not doing a top bottom thing. I'm just thinking left and right because I have an equal sign. I have a wall. Left side equals the right side. So whatever I do to the left side, I'm going to do the right side. I'm keeping a different balance than I did, say, back here on like these problems, right? Number 3. I did top and bottom because I did not have an equal sign. Does that make sense? See the kind of 2 different ways we keep balance? So this one is got a left and a right. It's got an equal sign. So equal sign. So I'm going to do left, right. Not top, bottom. So what am I going to do with left, right? Well, the whole common denominator. What's the whole common denominator? 1 of each. X minus 2 and X plus 2. So you give everybody X minus 2, X plus 2. Even the 1. Whoops. Can't really write here. X minus 2, X plus 2. And this one also. X minus 2, X plus 2. Everybody gets the whole common denominator. Top, 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 not bottom. Because I'm not thinking top, bottom, I'm thinking left, right. All the terms on the left, all the terms on the right. Is that good? Everybody see those 2 different ways we deal with fractions? 2 different ways, right? If there's no equal sign, we give them what they're missing, top and bottom. Just what they're missing. But if there is an equal sign, notice I'm not just giving them what they're missing. I'm giving them the whole thing, left and right. Same thing, left and right. Keeping the left and the right the same, right? Because the left and the right are equal. So if I treat them the same, they'll still be equal afterwards. That makes sense, doesn't it? Math should make sense. All right. So x minus 2's cancel. And what do we have left over? 10 and x plus 2. Over here we have x minus 2, x plus 2 times 1, plus, and right here, x plus 2's cancel, and we have 12, x minus 2. So this comes here, and this stuff all went there. And the 10 and the x plus 2 went there. Is that good to there? See how we canceled out the denominators? We got rid of the fractions? We good? Okay. And so now we got to solve that. It's a big mess. I'm going to put it on a fresh screen if that's okay. I'll come back. So what number was this? This was number 7. continuing on, 10 x plus 2, x minus 2x plus 2, and plus 12x minus 2. All good here before I move forward. Any questions on that so far? So equal sign, left and right. The whole common denominator, top, top, top. Cancel, multiply what's left over. All right, let's do it. So 10 distributes, 10x plus 20. Over here we FOIL. X squared plus 2x. Boom, boom. Minus 2x minus 4. Plus, boom, boom. 12x minus 24. There's the equal sign. All right, let's see what we got here. 10x plus 20, x squared. These guys cancel. Plus 12x minus 28. I did minus 4 and minus 24, which made minus 28. Good to there? So far, so good? Now, when we see x squared, we think?
Sea monster.
Sea monster, get a 0. Good, I hope that's reaching you. So whenever you see x squared with an equal sign, step 1 is get a 0. That's real important. If you're going higher in math, I was saying that to my pre-calculus students earlier today. X squared stuff was popping up in the middle of fancy logarithm problems. And I was saying, x squared, what do we do? Get a 0. Same thing, get a 0 factor, right? So when we see x squared, we think get a 0. So how do I get, now, when I say get a 0, that means get rid of everything on one of the sides. That'll be 0, right? Yeah, and so I'm going to get rid of everything over here. I'm going to do the opposite of all those guys. That'll make this side 0. Does that make sense? Whatever you do to one side, you have no choice but to do the same thing to the other, keeping the balance. That good? And then what do we got? X squared, what's that, plus 2x minus 48?
Yeah. So the negative 20 was, oh wait, never mind.
Carl, you always ask questions and take them back.
No, I got it.
Negative 6 positive
I
8.
answered my own question.
Okay, so we good there? Everybody see that, right? Do you see why I got 0 on the left side? Because x squared was already on the right side. So you always get 0 on the opposite side from x squared. Does that make sense? Whenever you see x squared, you think make the opposite side 0. Okay. And then factor, which means like the parentheses. So what times what multiplies to be 48? 6 and 8, right? Sign in the middle goes on the bigger. Plus 8 minus 6 is plus 2 in the middle. Remember, they got to multiply to be 48, add to be minus 48, add to be plus 2. So there they are, and then you set each. Remember step 3, set each equal to 0. Each one can be 0. So x minus 6 all by itself. I'm just going to run out of room here. X minus 6 all by itself can be 0. X plus 8 all by itself can be 0. Jump it over. Jump it over. Plus 6 minus 8. That was a lot of work. Hopefully that answer's there. Tell me that answer's there.
Yes, it's C.
Is it C?
I got it wrong.
But now you see it.
No, it's C.
Plus 6 minus 8. Is that okay? Questions on that? A lot of steps there. Good?
The next one is dirt.
So number 8. Current in a stream. Well, as soon as we read that, can we just stop right there? What equation are we going to use? The dirt equation. Distance equals rate times time. Yeah, oh yeah, and that other one, you're totally right. We're going to use that too. Yeah, so what Kara's saying, yeah, so we're certainly going to use the dirt equation, distance equals rate times time. That's correct, because things are moving. That's any time things are moving, right? Boats, trains, whatever. But yeah, specifically, when it says current, remember we had a specific thing we did for the dirt equations, the travel ones, when there was a current, wind or water moving. What is it? Boat plus the current, boat minus the current in the middle two rate boxes. Remember that? Because that's how you determine your total speed. It's however fast your boat's going, your little outboard engine, and then the water moving adds to your speed when you're what? With the current. But when you turn around, you go uphill against the current. That's upstream, and downhill is with the current. It adds to your speed. Everybody tracking on the difference there? So plus is downhill with the current, and minus is uphill against it. So that's the first thing you do when there's a current in the dirt equations. Put that in the middle two. It's always in the middle two boxes, the rate boxes, B plus C, B minus C. All right, the rest is pretty regular. If you get that down, you're in good shape. Let's keep going. It says the current moves at 4 miles an hour. So what's that?
That's the current, is 4.
That's the C, huh?
Equals 4.
So just cross out that C. We now know it's 4. So it's B plus 4, B minus 4. The boat travels 98 miles downstream. That's distance down. In the same time, 49 miles upstream. That's distance up, huh? Now I've got the 4 boxes on the left, and I just need the 2 boxes on the right.
It's going to be a combination of the 2 boxes.
How do we get these 2 boxes on the right? Do you remember? It's divide, isn't it? Right? Just think about, if you're not sure, just think about the dirt equation. You're trying to find these T boxes, right? Find T, just divide by R, huh? T is D over R, isn't it? So T is D over R. So it's going to be D over R. So it's going to be 98 over B plus 4 and 49 over B minus 4. Is that good? Distance over rate. Distance over rate. So I've got the 2 time boxes, and what did it say about time in this problem?
Time is equal to time. It's the same amount of time.
There it is. Same time. So this time, it's under T, and this time are same, are equal, aren't they? Those 2 are equal. Just got to set those equal and solve. I'm going to need to go to fresh screen. So we all got that down? This is number 8. Go here. Back. So 98 over B plus 4. B plus 4 equals 49 over B minus 4. Everybody got that down okay? Everybody see how we did that? Questions I can answer so far on the dirt setup? So again, when you have the 4 boxes on the left, the boxes on the right are by divide, aren't they? Left over middle, left over middle. That's how you always get the boxes on the right. Left over middle, because that's how you solve the dirt equation. Divide by R. T is D over R. So the T box is D over R, left over middle, isn't it? Okay, 49 over B minus 4, so 49 over B minus 4. Now, how do I solve this? Cross multiply, huh? Just diagonal, diagonal. So 98 times B minus 4 is 49 times B plus 4. Distribute, 98B minus something big. 400 minus 8, 392 equals boom and a boom. 49B plus just under 200, 196. 196. Okay, there's the wall. Trying to solve for B, the boat speed. What are we going to do when we have B in both sides? Get rid of one of them, huh? Subtract one of them. Yeah, totally. So subtract 49B. Gonzo. So what is this? 49B minus 392 is 196. Trying to get B alone here. Add 392. These are big numbers. And we get, bring this down, 49B. 588, there it is. 588, last step. Divide by the 49. It's 12?
Yeah.
B is 12. The boat speed is 12. Hopefully that answer's there.
Yeah.
There it is. Boat speed is 12. Questions on that?
90 or 80? Or 80?
All's good?
Wait, oh.
All right, I better keep moving. Okay, quality control, blah, blah, blah. 280 calculators, 9 of them bad. How many bad? 10,360 calculators. All right. Yeah, do you know that's just two equal fractions, isn't it? Called proportion, ratio, whatever you want to call it. That's just two equal fractions. That makes sense? So you just put,
280.
yeah, 280 over 9. Let me write that a little better. Bring it down here. 280 over 9 is 10,360 over x. And then just cross multiply. Is that one making sense? You can put them both upside down if you prefer. You know, you don't have to. You can put 9 over 280, x over 10, but you got to be consistent. I'm putting the total and the bad on the bottom, right? 280 calculators total, 9 were bad. 10,360 calculators total, x are bad, right? Which you can have those both upside down. That's okay. That'll work too. So now diagonal, diagonal. 280x is 9 times 10,360. Is that good? What's 9 times 10,000? It's like 92. What is it? 240. Thank you. And last step, divide by the 280. Does it come out clean or ugly?
333, yeah.
Just straight on the money, huh? 333. Oh, A. Yep. Is that okay on number 9? Just two equal fractions? Number 10. How do we do number 10?
It's going to be 1 over something and then...
Yeah, it's working together. Remember the working together? Number 10, there's clearly they're working together. Remember the working together formula? 1 over A plus 1 over B is 1 over together. Well, that's a good one to put on your 3x5 card. So let's go there. All right. So, yeah, so working together. Is always 1 over A plus 1 over B is 1 over together. Okay. So, what do they give me? It say Jeff is 5 hours longer. What do we do with that? Any word problem.
X plus 5.
X plus 5. It's like saying 5 more, isn't it? 5 more. Jeff is 5 more. So I make this 1 over X plus 5, which means the other one is just X. Remember, whenever there's an X plus something or minus something, there's also a plain X, isn't there? You guys tracking with me? And then together, 6 hours together. Working together takes them 6 hours. So they're giving me that. There's our equation. You good to there? And you could switch the order in the first two. If you had the 1 over X first and the X plus 5, that's fine. Doesn't matter. As long as the 1/6 is on the right. So remember the working together? 1 over A plus 1 over B is 1 over together. Okay, now, how do we solve that one?
Find what the common denominator is.
Yeah, do we have an equal sign?
Yes.
Sure. So I'm not thinking top, bottom. I'm thinking left, right. Just top, top, top. Not bottom. Because I'm just doing the left and the right. Here's the equal sign, the wall separator, huh? All right, so what is the common denominator? Everything. 6x, x plus 5. 6x, x plus 5. 6x, x plus 5. Is that good? Top, top, top. 6x, x plus 5. All the way across. And then, that's what we always do, right? With an equal sign, the whole common denominator, top, top, top. Cancel the x plus 5. What do you have left here? 6x. Cancel the x's here. 6 and x plus 5. Cancel the 6's here. X. This is going to be a long problem, isn't it? Didn't realize that. 6x plus distribute. 6x plus 30. Multiply this. X squared plus 5x. Good so far. And 6x and 6x, 12x.
Ooh.
Good to there. How we doing? What should be in our minds now? Get a zero. Because x squared is on the scene. You're getting used to the identification process. A lot of math is kind of knowing what to do when. X squared, get a zero, huh? And where? Opposite side from x squared. That means this left side needs to become zero, doesn't it? Because x squared is on the right side. You always make the opposite side zero whenever you see x squared. All right, so let's do it. So that means go minus 12x minus 30. And whatever you do to one side, you got no choice. Do the same thing to the other. Minus 12x minus 30. I'm running out of room again here. So when we do that, I'm going to go to my fresh screen. We've got 0 equals what? X squared
Minus 7.
plus 5x minus 12 would be minus 7, huh? Minus 30. Yeah, so it'll be 0 is x squared minus 7x minus 30. We okay with that? Everybody good to there? This one's a mess. We're still not done. We okay so far?
This one can actually factor.
Now this one will factor. What times what multiplies to be 30 and can somehow add to be minus 7? 10 and 3. Sign in the middle goes on the bigger. So minus 10 plus 3, that makes minus 7 in the middle. So then you set each one of these equal to 0 separately, remember? Because if two things times to be 0, either one could be 0 to make that happen. Move that over. Positive 10, move that over. Negative 3. How long did you take to build that fence? Negative 3, no.
No, it would be
Forget
10.
that. Yeah, so throw away that negative 3. That's a bogus answer. You with me? We're talking about how long it takes, how many hours for Jeff or for Bill or whatever. It's not negative 3. Everybody good? I just threw that away? So it's 10. And how do we get the other answer? One of them's 10. The other one's not negative 3.
It's add 5.
Yeah, you go back. What was your setup? Right here and right here were the A and the B, the 2 times, huh? The A and the B. So one of them's x, the other's x plus 5. So one of them's 10, the other's add 5 to that, 15. 10 and 15 are the 2 answers. Everybody see that? Can you go back to the A and the B?
None of the above.
And what are they even asking for? How long would it take Bill? Which one's Bill? Is Bill the faster one? Jeff is longer.
Bill's just plain X.
Bill's longer, so, Jeff's longer. So Bill is the slower, Jeff's the bigger number. How about that? Jeff is the bigger number. I'll just leave it at that. Jeff is 5 more. So Jeff is the 5 more. So this is Jeff. So Bill is the 10, right? Isn't that what it says? Jeff is longer. Jeff's more. So Bill's the 10. So the answer's 10. It's not there. After all that work. None of the above. But it would have been 10. Everybody get 10 on that? Final answer would have been 10, not 15, 10, right? Is that good? That's a painful one.
Yeah.
Questions? All right. All right, so what do we do when we got fractions left? We got an equal sign left and right, top, top, top. Top, top, top. So what's the common denominator on this one?
X.
Just x, huh? So just go top, top, top cancels here, cancels there. 19 equals 5x minus 1. Good so far. Add the 1, add the 1. 20 equals 5x. Last step to get x alone. Divide by 5. X is 4. D. Good? All right, let's keep going. Number 12. Oh, another same kind of thing. Can I move on from that? You guys got that down? Okay, so number 12. Okay, so same thing, number 12. Common denominator, top. Right here, so we get 16 over x minus, oh, we're supposed to never subtract. So move that negative up on that 16. Move it up on the 16 like that. Never subtract, multiply through by the common denominator. What is the common denominator? X minus 5, x minus 5, x minus 5. Is that good? Multiply through by the common denominator, x minus 5, all the way across the top. Top. Good? We only need one of the x's, huh? Remember, for common denominator, you just use one of every type? That good? All right, let's cancel. X cancels x. What do we got here? 16 x minus 5 plus x minus 5's cancel. Negative 16x. Here the x's cancels for x minus 5. Got rid of all the fractions. So distribute. 16x minus 80. Plus a negative 16x is just minus 16x.
Yeah.
Doesn't really matter, right? Boom, boom. 4x minus 20. These guys cancel.
Yeah.
That's nice. So, add the 20. That's what? Negative 60 is 4x. Last step. Divide by 4. Boom. So what is that? Negative 15. 60 divided by 4. Negative 15. Hopefully that answers there. Yes, B. How we doing? I'm just talking, trying to read your face. Is it good? You want questions on that one? We're only about halfway through. I got 20 minutes. I got to keep moving. So I'll keep moving. If it's too fast. Okay. So what do you do when you have a 2 power on parentheses? You got to write 2 of them, huh? You got to write 2 of them like this. And FOIL. I think you know that. Boom. Boom. So 10x, 100x squared. 10x times minus 4 root 2 is minus 40x root 2. He's done. And then this guy's going to go.
Minus 40 root 2.
And then now for the big deal. 4 root 2 times 4 root 2. First off, negative times negative. Positive. 4 times 4, 16. Root 2?
Plane 2.
Plane 2. It's going to be 32. You can make a root 4 if you want, but what is root 4? Plane 2. Everybody see that? Remember, outside stuff multiplies outside stuff, inside stuff multiplies inside stuff? On that? We good? Everybody good with all that? Right? So then these, what we got? 100x squared minus 40 is minus 80x root 2 plus 32. There we go. See? $14, you can just hit the buttons on your calculator. If you know how to do that in your calculator, that's fine.
I'd rather know how to do that.
3 to the power, you might have an up arrow or an x to the y or something like that. You might need to put parentheses, maybe not, sort of depends on your calculator. Something like that might do it. That's totally fine. Anyway, I'll show you how to do it by hand as well.
The 5 jumps around, goes into the hook, and then it still takes
1 over. Yeah. Well, yeah, your calculator might not show it exactly like this. I don't know. Whatever. I'll do it by hand. So, so to do this problem, 3 to the minus 4/5. What is a there's a couple issues here. First off, what is the negative part of there's two weird things. The fact that the power is negative and the fact that the power is a fraction. Both cause weird things to happen. What does a negative in the power zone do, first off? Just flips the whole thing, doesn't it? Just flips the whole thing. I don't mean the power. It doesn't flip that forward. I just mean 1 over, and then the power becomes positive. Good with that, first off? That's what always happens with a negative power. It's 1 over the whole thing, right? I always say he's negative, he's unhappy where he's at, he wants to jump to a different job. Right? He's unhappy. Jumps down here. Now what happens with the fractional power? The 5 swings into the hook. Scooby-Doo falling through the trap door. Did I make that analogy? Mm-hmm. Anyway, all right. So it just falls. It's like its denominator falls down into the hook, right, into the little trap thing. So it's 5th root. And the 4 stays put. 3 to the 4th, still 3 to the 4th. The 5 just swings into the hook. Good? And then what is 3 to the 4th? Yeah, it's 81. So it's answer C. 3 to the 4th, you use calculator. 3 times 3 times 3 times 3. 81. There it is. C. Is that good? Okay, I better. All right, so right over here. So cube root of 112, cube root of 60. I just start breaking them down. What's in a 112? I don't know. 2 times 56, 7 times 8, 2, 2, 2. I'm running out of room there. 56 is 2 times 2 times 2. So bring these guys down. There's that one, 16. 4 times 4, 2, 2. Here, let me just bring them all the way down. It's good to have them all on the same level. I think it's easier. 2, 2, 2, 2. All right, so there's all the little pieces that came out of that 112 and that 16. Everybody see how I did that? Just broke it all the way down. All the little stuff. It came out of the 112 and out of the 16. Now, there's a 3 in the hook. So that means it's a 3 for 1 deal at target. So 3 twos. 3 twos. Each group of 3 sends 1 representative out. The rest stay in. So these 3 twos will send 1 2 to the front. These 3 twos will send a 2 to the front. What's left in? 7 times 2 times 2. 7 times 4? 28. So that's 4 cube root of 28. There it is. Does that make sense? Right? So 1, 2 from each group comes to the front. That's 2 times 2 is 4. Cube root, what's left inside? 7, 2, 2. Multiply 7 times 2 is 14, times 2 is 28. Okay? Questions? How we doing? We good? Trouble finishing here. All right. So, 10 root t plus root 2, 4 root t minus root 6. Okay, so we're going to FOIL, right? So first to both. What happened when you multiply? What's the rule for multiplying? Outside stuff with outside, inside with inside, right? Outsiders with outsiders, insiders with insiders. So 10 times 4 is 40. And what's root t, root t?
T.
Plain t. Remember, 2 twins in, 1 breaks out. That's the break out of the root rule. 2 in, 1 out. Right? Because there's nothing in those hooks, which means 2. Good? Minus. Now the 10 root t hits the root 6. The 10 stays on the outside, 6t on the inside. He's done. Next, this guy is going to go to both. Plus 4 root 2t minus root 12. Is that good? 2 times 6 makes 12. Now, one thing left to do. 12 can be broken down. There's some pairs in there. 3 times 4. 4 is 2 times 2. 2 twos in? 1, 2 out. The rest of the stuff you could try, you could look at it. It's not going anywhere. Like 6, that's just 2 times 3. There's no pairs in there. You know, nothing else can break down further but the this root 12. So the rest will stay the same. So 40t minus 10 root 6t plus 4 root 2t. And then the root 12 is 2. It's minus, isn't it? Minus 2 root 3, right? The 2 2's, send 1 out, 3's left in. There it is. So, which answer is that?
D.
Is it D? 40t plus... Oh, yeah, they have a different order than me, but yeah, same answer. Good? 17. How do we solve 17? And 18. I mean, the same thing, basically. Cross multiply, both of them. P over 1, I over 1, diagonal, 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 diagonal. Right? Both those. Can I go to a new screen? All good? Okay. So, P over 1 is A over 1 plus RT. Right? You just put the P over 1, make it look like a fraction. You just go diagonal, diagonal. P times 1 plus RT and 1 times A. Good. That's a 1. That's not an L. It's a 1, right? So distribute. So P plus PRT. 1 times A is just A. So P times 1 is just P. We get to here, we got to remember what the ball is. Got to keep your eye on the ball. Who's the ball here? R. So we got to get the R alone. Here's the wall. R is saying, I want to be alone. Get rid of all this stuff that's with me. So what do I do first to get him alone? Subtract that P. Starting on the outside, huh? Subtract that P first, exactly. And we have PRT is A minus P. And finally, to get the R alone, divide by the P and the T. P and T. There it is, R's alone. A minus P over PT? Yep, C. Answer C. We good? 18 is going to be the same. It's going to be a little easier. Got that one copied down. Maybe I can... Well, I better go... Yeah, I better get a fresh thing. If you got that down, I'll go to a fresh one. All right. 18. So for 18, I equals KE over R. Put this over 1, diagonal, diagonal. IR is 1 times KE, which is just KE. So divide by, what we're trying to solve for here? R. So divide by the I. Boom, there it is. 1 times KE is just KE. KE over I, it's answer A, huh? Right? I didn't get fooled that time, though. Yeah. All right, we good on that? So, a few more. So 19. It's dividing. Notice it's divide in the middle. So that's not bad. I don't have to get common denominators, all that kind of stuff. It's just factor, flip the one on the right, cancel. No common denominators, no giving them what they're missing, none of that, right? It's just divide. You guys with me on that? You getting the big picture? It's only the adding, subtracting fractions that are a pain and common denominators and all that. All right. So factor. How do you factor y cubed plus 3y? Take out a y. And the other one, y squared minus 9 is y plus 3, y minus 3. I'm going to flip this one. So it'd be times, and put the y squared plus 2y minus 15 on the top, the y squared plus 12y plus 35 on the bottom. So I flipped it. Now I got to factor that, so that's going to be, I'm just going to do that quick. 5 and 3, sign in the middle, sign in the bigger. The bottom one, to be 35, it's 5 and 7, both positive to make 12 in the middle. And then the other one, y times y squared plus 3 over y plus 3, y minus 3. Cancel what you can. Y plus 5, y minus 3. That it? Guess so. So we're left on the top. Y times y squared plus 3 over y plus 3, y plus 7. We can't cancel these y squared plus 3 with the y plus 3. They're different. So that's just it. It's not one of those answers. Is that none of the above?
None of the above.
None of the above. It's disturbing. All right, Abraham.
Can you just consolidate the top, or no?
Just you mean just FOIL it?
Yeah.
Sure, it's okay. It's not wrong. Still not there. Okay, so remember LCM, you gotta do the box thing for the numbers? Like 50, 90, and 45. Remember, it's been a while since we've done that. Remember the box thing? So for the out front numbers, do that and say, okay, what goes into all those? Like 5? 5 goes in there 10 times, goes in there, what, 18 times? And just use your calculator 9 times. What else goes into like a couple of the numbers? Yeah, you just keep going as long as you can. I'm going to do 9, good idea. 9 goes into 18 twice, goes into 9 once. 9 doesn't go into 10, so just bring the 10 down. Remember this kind of box thing? What goes into 2 of the numbers now? 2. 2 goes into 10 5 times, goes into 2 once. 2 doesn't go into 1, just bring it down. That's it, we're done. The only thing left is 1. We don't do 1. So then you multiply these on the outside in your calculator, remember? And you get something. 5450? And, well, this is the only number with 450, huh? That's helpful. Yeah, and then you just take the highest x. The highest x is x to the 5th. The highest y is y to the 4th. Remember, it's just highest. Highest x, highest y. Let's try 21. LCM. Now, for a 21, you got to factor the first one. Take out an m. And then the second one, factor, what is it going to be? Yeah, it could be 2 and 4 to make 8, both negative, to make negative 6 and positive 8. Okay. So what's the LCM going to be then? Remember, least common multiple, least common denominator, same thing. You're shopping and you're going to buy one of every type, the most expensive one, the highest power one. So you're going to buy a single m, only one m minus 2, and only one m minus 4, just one of each. M minus 2, m minus 4. Wait, they put an x in there? Is that like a trick?
Oh, it must be something.
Yeah, it's none of the, is it none of the above again? Yeah, it's none of the above. So, I don't know why they put an X, but anyway, that's kind of a goofy question. Is that okay? So you got to factor them on an LCM problem. On that one, anyway. All right. Simplify a square. What's in the hook on 22?
2.
Nothing, 2. So break down the 72 is the main bit of work there. 72 is 2 times 36, which is 6 times 6. You can actually stop right there and ship out a 6. You don't have to keep going 2, 3, 2, 3. As soon as you see a matching pair at any level, you can ship it right then, right? So it's 2 for 1, ship out. So now the 6 is coming out on the top because it came from the 72, which was on the top. Keep the top stuff top and the bottom stuff bottom. The bottom's going to be x squared. Remember, you divide the powers by 2? Am I going too quick? Remember, you divide the x to the 4th. You divide the powers by the little hook number. So the power 4 divided by 2 gives you 2 on the bottom. And on the top, r squared divided 2 r's. So how about that? 2 r's in the top, 1 r out. Whoops, I erased it. 1 r out, and the y is left in. 6r root y over x squared. 6r. I don't see it. Is it none of the above again?
It's
No.
2y. It's root 2y.
Why is it 2? Oh, yeah, I forgot about that 2. Yeah, I better be careful. Don't be too quick and hasty like I'm being. Yeah, that 2 was left in. I forgot about that 2. That was left inside along with the y, so it is a. Is that good? 23, same thing. You got to break down that 28. 28 is 4 times 7. That's 2, 2. 2 2's in, 1 2 out, and 1 a out, and you leave behind a 7 and a b. On the bottom, you get out a c. Is that what it is? Yep. Everybody good on that? The 28, 2 2's, out comes a 2, but the 7 is left in. 24, rewrite with rational exponents. What does that mean, rational exponents? Yeah, change it to a fractional power, swing the 2 back. Exactly. And bring it over here. So this is 24 over here. X, the root of x of, yeah, what's in the hook there is nothing, which means 2, as you know. Whoops, I'm scribbling it all up. right? There's an understood 2. Swing Scooby-Doo back, right? X to the 7/2. There it is. That's the same thing, right? Remember the swinging? You can go from denominator to hook, denominator to hook. Both are same thing. 2 different languages say the same thing. 25, got to do a graph. You just plug in some numbers. Graph, plug in some numbers. So for 25, this is y. Remember the g of x, any function letter is just y. I would just do as simplest numbers I can think. I would just look and go, Look, what's real nice to put in there? 3, because that'll make that 0 and it'll go away, right? Remember, you can put anything you want in for x. How about 3? It's nice. It's a nice, and put in 3, and y will be 2. 2 plus the square root of 3 minus 3, huh? When you put a 3 in, which will just be 2. So there's 1 point. Now I can just look down at the options and see which ones have over 3 up 2. Over 3 up 2, which is where? 1, 2, 3, right here. They should have that over 3 up 2 dot. The graph should go through that dot if it's the right graph. Now, if that's not enough information, you can do some more points. Let's go look. What if I put in like 0 for x? What would I get?
0 minus 3.
0. 2y equals 2 plus the square root of 0 minus 3. 2 plus the square root of negative 3. What's that? That's a no. You can't take the square root of a negative number. That's imaginary. It's not real. So that means no. If you put in 1, you'd also get negative in the root. No. If you put in 2, 2 minus 3, negative 1. Those are all no-nos. No, no, no. So which means at over 0, no. At over 1, no. And at over 2, no. So there should be no graph there.
Oh, so
The graph doesn't go to the left. It only goes to the right of 3, huh? So now let's go 4.
south of
If you plug in a number like 4, you're going to get 2 plus the root of 4 minus 3, which is 2 plus the root of 1, which is 3. So it's going up. 4, 3, it's going up to the right. So that's how you know it's D. It's going up to the right.
how is 2 plus the square root? The square root of 1 is 1.
2 and 2 plus 1 is
Oh, okay.
3. All right, there we go. Well, the